Alright guys, we're gonna get crunk with alcohols today in our continuation on the series on organic chemistry. Now we're gonna introduce you about alcohols. Now what's the first thing you think about alcohols? You think about drinks and getting drunk and partying in Las Vegas and all that good stuff. Well, maybe not so good stuff, but it all depends. But you see, that's not what alcohol is all about. Alcohol is in like everywhere. It's all defined by the functional group of OH. That's what alcohols are defined as. For example, isopropanol is a or isopropyl alcohol is a very useful disinfectant that you can get at the pharmacy. All right, and that is an alcohol. And methanol is a common organic solvent that you can find in a lab when you do some sort of chemical reactions. So let's just start talking a little bit about some basic alcohols. Okay, so when we talk about naming and writing the structure of alcohols, again, it's all defined by the prefix of what the alcohol and prefix is, which is meth, eth, prop, and all the whole stuff, and you add it with an all, right? So if the formula or the molecule has only one carbon atom, you will call it methanol, defined by one carbon atom and surrounded by three H's and a functional OH group. All right, and then we're going to talk about ethanol. We'll have two carbon atoms in its molecule, so two carbon atoms, and it's surrounded by H's and one functional OH group. Right, propanol has three carbons and is surrounded by H's and one OH functional group. So you can draw propanol as in 1, 2, 3, followed by a whole bunch of hydrogens connected to the carbon and a lone functional OH group at the end. Or you can draw propanol in its isomer, its structural isomer, where the OH functional group is at the center carbon. Now, when that happens, you will have isomeric names that are different for the function, depending on each functional group. And so, when we talk about the propanol for the one here, we will write it as, we could count the carbon atoms 1, 2, 3, right? Or the other way around, 1, 2, 3. So you could have either a name of prop 1 or proper 3 or. And because of its nomenclature and the rules of naming organic molecules, you would use the smaller of the two number, and so this name, the propyl-3-ol, is incorrect, and the correct name is propyl-1-ol. Okay? Here, the next isomer, we can count the carbon atoms, and no matter which direction you count the carbon atoms, you will find that it's always on the second carbon. So the name will be propyl-2-ol, no matter what you say. And in class, we'll do some more activities and naming longer chains. All right, so let's talk about the most useful alcohol there is for us in IGCSE. And you got it, it's ethanol, the most familiar alcohol for all of us. It is an awesome solvent. Why? Because of its OH group, which allows it to dissolve things like water, and it can also dissolve organic molecules, like because of its CH functional group, all right? Although CH is not really a functional group, but it's the properties of that CH bonds allows it to dissolve other organic molecules. You can see ethanol using in some processes, industrial processes, like in US, 7-Up in order to make 7-Up, I'm led to believe that Pepsi uses ethanol as the organic solvent as they make 7-Up. Now, the ethanol is not in the final product, but it's just part of the processes, industrial process as they go and make the beverage. All right. Ethanol is also an effective biofuel, and you can see ethanol about up to 10% of ethanol in use in the U.S. and the introduction of flex fuel cars. Flex fuel is simply just a marketing name for a type of cars that are able to use, let's say, ethanol as its fuel source. So flex fuel cars, you will see that in some literature about flex fuel cars in America, but it hasn't really caught on. Another country that loves to use biofuels is Brazil, and Brazil has what they call, they blended the two, petrol and ethanol and pump it into cars in what they call gasohol cars. Gasohol. I think that's how you spell it. Okay, gasohol cars. And these cars with the modified fuel tank are able to accept ethanol or petrol. Now, why do they need to modify the fuel tanks? It's because of the OH group, right? Because ethanol has this OH group. It's very likely to attract moisture to the fuel tank. And also, when it's in that fuel tank, some of it may decompose into water. And so, the fuel tank needs to be able to contain water and the decomposed ethanol. All right? And finally, our ethanol makes awesome drinks. The slow process of fermentation, which we will talk about later, allows it to allows alcohol drinks to have flavor. All right? So, let's talk about how ethanol is now made. There are basically two processes that you need to know in how ethanol is made. The first one is the old classical traditional method, which is by fermentation. Fermentation, you basically take a sugar sauce, which is glucose, for example, and you put yeast under slightly high elevated temperatures and slow, in a capsulated environment. You would, the yeast would catalyze, well, not a very fast catalytic reaction, but will catalyze the sugars and break down into ethanol and CO2. Now that CO2 makes ethanol drinks pretty nice. And you can purify the product here by a process called fractional distillation. And I'm sure you guys are familiar with it. So you basically boil it, because the ethanol is going to be in liquid, in water, right? So you basically have a reaction vessel, you heat it up and under reflux, and you will have a cooling pipe. And because ethanol boils at a lower temperature compared to water, most of the ethanol will start evaporating and condensed by the condenser. And you collect almost pure ethanol outside, and what you're left with inside the reaction vessel is water. Now, industrial processes are much bigger than this, but the principles are quite much the same. All right. Another method to make ethanol is by the addition of steam, addition reaction of ethene with steam, and now you get ethene here, which is a product, a byproduct of oil and gas hydrocracking, or oil and gas cracking. When you crack, you get two products. One's a long alkane chain, and you get ethene. Ethene now, when you add steam into it, will break up the double bonds, and one of the bonds will combine with H, and the other one will form an OH. And this condition is operated 300 degrees at 70 atmospheric pressure. So it is pretty hot, and energy, it consumes a little bit of energy in order to start the reaction. Okay? So, oh, by the way, fermentation, none of this involves hydrofracking or cracking. I mean hydrocarbon cracking. Okay, so don't get those two processes mixed up. All right. So, what are the pros and cons of using fermentation versus addition reaction of ethene method? Well, the pros of fermentation is that it's a renewable resource. That means you get to produce ethanol over and over again by using renewable organic matter, right? Like corn that we grow, the sugar cane that we use. Okay, and fermentation. The beauty about fermentation is that you don't really need advanced technology. You can ferment things at home at your own pace. Like just put a bit of sugar and rice and yeast, and you can like make your own alcohol drinks. Well, not that you should do it because it's a controlled process. Okay, maybe not so much in Malaysia. And the slow fermentation process, and depends on the yeast that you have, does produce some flavors. You know, your ethanol will have a bit of a flavor, so that's kind of cool. The drawbacks of using fermentation is that it's a very, very slow process. It takes about 2 weeks, maybe more than that, and the yields are usually low, about 4%. When each time you make a small batch of it, and in order to grow the crops that we use for making the ethanol, you will have to chop down a lot of trees and clear land just to grow the crops. So this is a big problem in Brazil, where they basically wipe out a lot of rainforests to grow sugarcane. All right. And so, what are the pros for using the addition reaction with ethene? It's fast. The outflow, the production flow is continuous. So you continuously make lots of ethanol, right? And this is a very cheap process for countries that are oil exporters, like the United States, Saudi Arabia, and stuff like that. And the yields that you get from alcohol, the yields is high yields. It means you get high percentage of ethanol, over 80%, 70%, stuff like that, right? The cons is that the ethene is a byproduct of the oil and gas industry, and so petrol and oil and gases are not renewable resources. They are non-renewable, so we may run out of it eventually, all right? And the process to set up this ethene reaction with steam is costly, and you need high temperature and high pressure just to get the reaction going as well. So that itself, operational cost, is quite costly. All right. And finally, there are two reactions that you kind of need to know about in reactions involving ethanol. So first one is burning ethanol in oxygen. What you produce is CO2 and water. That's easy peasy. Another reaction is to use ethanol and mix it with ethanoic acid, which is the primary chemical in vinegar. And when you mix the two together, you get a very sweet scenting ethanoic chemical and water. Well, we'll talk more about all these things in class later.